Hi, this is the interim test number 3. Remember that you're going to have CAASPP testing this week, and we want to make sure that we correct in pen our work that we did on the graph paper, and then study for the CAASPP using this video. You can earn more points for your quiz score also with this, so you'll be turning it in after the CAASPP. I'm going to go relatively quickly, so be sure that you pause anytime that you need to take notes, and we will share all the good stuff for these questions. Question 1. The dot plots show two students' scores on 12 history quizzes. So each of these are representing a score for Lolo and Amy. Which statement correctly compares the median and range of their scores? The median of Lolo's score is greater than the median of Amy's score, and the range of Amy's score is greater than the range of Lolo's score. So they want us to look up the median and the range. To find the median, it's the number of jumps to the middle. If there's two numbers in the middle, like an even number, since there's 12, it's going to be an even number, add the two numbers and divide by 2. Or we just think, what is the number in the middle of those two? So if you were able to take away 5 dots from this side and 5 dots from that side, you'd see the two middle dots are one in the column for 14 and one in the between 14 and 16. So that's going to be 15. So right between 14 and 15 would be 14.5. That's the median. For Amy, it's the same situation. You take away 5 from this side, 5 from this side, and that leaves the two middle scores of 14 and 15. That's what this empty spot is. And so the median would be 14.5. So this first choice is out. Forget it. Choice B, the median and range of Lolo's scores are greater than the median and range of Amy's scores. Well, we just found out the medians were the same, so forget that one. The medians are equal. Okay, this one's looking good. And the range for Lolo's scores is greater than the range of Amy's score. Well, the range for Lolo's score is the highest number minus the lowest number. So the highest number here is 19, the lowest is 12, 19 minus 12 is 7. For Amy, the highest is 18, the lowest is 10. You don't count the numbers on here, just where the dots are. So the dots are between 18 and 10. 18 minus 10 is 8, so the range here is 8. It looks like Amy's range is one more than Lolo's range. So Lolo's scores are greater for the range. That one's no good. Let's hope that D is good, because we really need an answer that's right. Choice D, the medians are equal. That's true. And the range of Amy's scores, which is 8, is greater than the range of Lolo's scores, which is 7. Okay, whew, that's true. Choice D is right. Question 2. In math class, Mrs. Carlton will choose a student to write a homework problem on the board. The probabilities that given students will be selected are shown below. So we went ahead and we realized that each of these are like pennies because they're into the hundredths column, and a hundredth of a dollar is pennies. So this is like Brad is having a probability of 64 cents out of a dollar, or 64%. If you want to do it as a fraction, it would be 64 over 100. You could even reduce it down to be 32 over 50. But just thinking 64% is how much probability Brad has. Emily only has like 1 penny out of a dollar, so that's 1 out of 100, 1%. Stephen has 4 cents out of a dollar, or 4%, and Marge has 31%. So we have to see which of these answers is going to be true or false. So we'll reveal these. Question number 1. It is unlikely that Stephen will be chosen. Well, poor Stephen only has 4 out of 100, or 4% probability. So I would say that's true. It's unlikely. It's not going to happen too often that Stephen's going to be selected. It's possible, but it's unlikely. So that's true. It is very likely, I misread this before. I read it 3 times as unlikely. So you got to watch yourself, make sure you're reading the actual words that are there. So it is very likely that Marge will be chosen. Well, Marge has a higher percentage than some, but not as high as Brad. She has half the chance of Brad, so I don't think very likely would be the right wording for that. So I would say false for that one. Stephen is 3 times as likely to be chosen as Emily. Well, Stephen is 0.4 and Emily is only 0.1. To get from Emily's score of probability up to Stephen, you'd have to multiply by 4. Not by 3. I think the 3 times is there to mess me up because the difference between them is 3. But it really would be 4 times more likely to be chosen. So 4 times would be true, but this 3 times is false. And now the easiest ones are down at the bottom. The least likely person to be chosen is Emily. Yep, she's only got 1 out of 100. That's true. And the most likely person to be chosen is Brad. Yep, he's got 64%. 64 out of 100, that's true. So it is true, false, false, true, true. Remember that even if you just get parts of these right, you get points. So don't ever quit. Always read down to the last ones. Here are the easiest ones for the last ones. Okay, on to question 3. It's already been 5 minutes. We're probably going to need 2 videos for this, but I'm continuing to truck along as quickly as I can. Thanks you guys for holding on and putting your best effort forward. It really matters. It's going to make a big difference, and it's showing what you've got in you for your life, for how you're going to attack life situations and future tests for finals and things like that. Okay, question number 3. The nutrition committee at a middle school has decided to find out which vegetables are most popular among 500 students at the school. So I underlined 500. Which sampling method is the best choice to use? A, ask the parents of 100 randomly chosen students to choose their favorite vegetables. Okay, if you're going to be talking about vegetables, I think you should talk to the person that's going to be eating them. Ask the students. So I'd say forget A. That seems kind of silly. Ask all the students from a randomly chosen class of 25 to choose their favorite vegetables. Okay, so that's a random choice of 25. That's something to think about. Ask 100 randomly chosen students from the student population to choose their favorite vegetables. Well, 25 may give you, I don't know, maybe a bunch of friends. They all like celery for some reason. 100 is more likely to give you a better sampling of 500, and this way you can just take all this data, multiply it by 5. Whereas this, you'd have to multiply by 20 to get to what the total would be. So I'd say ask more kids. That would be better. And then D, ask 25 students who have purchased vegetables during lunch. Well, sometimes people need to purchase vegetables if they need to do a particular type of food intake. I wouldn't say that the purchase part necessarily has to do with what people have as favorite foods. Maybe there was some other type of food that people wanted more that day, but normally they like carrots or whatever. So the greatest input that's random is the number choice that I chose, choice C. Question number 4. The spinner shown below is being used in a game. First question you have to ask yourself, is it a fair spinner? Are all the spaces the same size? And they are. So each number has the same probability of being spun, 1 out of 8. And they ask, what is the probability of spinning the arrow once with the result being an even number less than 6? So you have to think of what makes you happy if you're looking for an even number less than 6. Well, the only even numbers are 2, 4, 6, and 8. Can't count 6 because it's not less than 6. It's 6 exactly. So less than 6 would be 4 and 2. So the 2 combos that would make me smile are 2 or 4 if we spun those, out of a total of 8. So remember, probability is what makes you happy compared to the total, 2 out of 8, or if you reduce that down, 1 out of 4. Now they ask you, use the on-screen keyboard to type the correct probability in the box below. So you're going to look for, this is my eyes looking for the 2 boxes that have the fraction bar in between. Then you're going to input a 1 in the top box, and then click down to the bottom box and input a 4. And then you're done. That's 1/4. Question number 5. Eva flips 3 fair coins, fair means 2-sided, and notes the results. So she's doing an experiment. So this is experimental probability. She repeats this experiment 10 times. In Eva's trials, all 3 coins land on tails 2 of the 10 times, and all 3 coins land on heads 1 of the 10 times. Which of these statements are true? Choose the 2 correct responses. Double underline 2, and make sure that you put over here the number 2. You need 2. That's your goal. You just get 1, you're going to miss out. The theoretical, okay, so this is again the idea that we talked about, theoretical probability that all 3 coins will land on heads is 1/8. Well, you have heads or tails, so heads is going to be 1 out of 2. And since we're going to spin the coins 3 times, that's 3 different events, so it's 1/2 times 1/2 times 1/2, which is 1/8. That's what they said. The theoretical probability that all 3 coins will land on heads is 1 out of 8. And if you wanted to see it in outcomes, the one that would be all 3 heads would be this path, heads, heads, heads. We can see there's a total of 8 different outcomes. You could have tails, heads, heads, tails, head, tails, 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 heads, tails, 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 head, 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 tails, head, tails, head, head, tails, tails. So the total of 8 different outcomes. Choice B says there are 6 possible outcomes for the experiment of flipping 3 coins. That's just not true. Forget that one. So choice 1 looked pretty good. Choice A, so we're thinking that it's A. Put a check mark there. And no good for B. Eva found the experimental probability that all 3 coins lands on tails to be 1 out of 5. Okay, well, we got to look at her experimental probability. All 3 coins lands on tails 2 of 10 times. So if she found 2 out of 10, well, that would equal 1 out of 5. So that would be true. Eva found the experimental probability of all 3 coins landing on tails to be true 1 out of 5 times. Okay, next, the theoretical probability that at least one of the 3 coins lands on tails is 3 out of 8. Well, there's a lot of combos that have tails in here. It's more than 3 out of 8. As a matter of fact, at least one of the 3 coins landing on tails is going to be right for all except for this one path that has heads, heads, heads. So only 1 out of 8 is going to be coins landing on tails. So it's not 3 out of 8. So this should be, no, that would be only 1 out of 8. So that one's no good. Forget that one. Choice E. Eva's experiment is flawed because the theoretical probability of heads on all 3 coins is different from the experimental. Well, that's true. Uh-oh. There's 2 things that we need to figure out. We have a couple things that we think are right. We can't argue with the theoretical probability that all 3 coins will land on heads is 1 out of 8, because heads, heads, heads is just this one path, heads, 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 and it's 1/2 times 1/2 times 1/2, which is 1/8. So that one for sure is right. But these other 2 are a little bit weird. They're worded strangely. Eva found the experimental probability, that's what she did up here, that all 3 coins lands on tails to be 1 out of 5. She did. 2 out of 10 is 1 out of 5. Eva's experiment is flawed because the theoretical probability of heads on all 3 coins is different from the experimental. That's true too, but it says choose only 2 correct responses. I would go with A and E. So sometimes you just have to go through and decide what you think is the best idea. You may not be positive, but you've used all the different information that you've got, and you're trying your best. And you will get credit for that. You'll get points for that. Okay, moving along. Question number 6. Well, this is a fun one. The number of pages per book in the young adult fiction section of the library for a random sampling of 25 books is shown below. So I just counted up all the ones that had less than or below 100 pages, and there were 15 in here. And the ones that had more were 10 out of 25. I made sure that the 15 and the 10 added up to make a total of 25, so I didn't lose any data. Then if I were going to convert 15 out of 25, if I do my conversion factor times 4, it's going to equal 60 out of 100, which is 60%. Same thing here, times 4, 4 times 10 is going to be 40%. So, letter A choice. The percentage of books in the entire library with less than 100 pages is 60%. Well, I didn't want to pick this because this is only the young adult fiction section. So I thought, no good. That's not clear. So I'm going to say, forget that one. A second random sampling of 25 books in which 42% of the books have less than 100 and 58% of the books have more than 100. 58 have more than 100, supports the results. Okay, that's kind of the flip of it. If they had the numbers flipped, then